let's move on to example 2. And example 2 is really important. And it illustrates really something very critical in this chapter, which is learning how to simplify expressions. By dividing monomials. All that you're doing, though, is stuff that you've done in the past, and I really want to emphasize that. It's going to look slightly new, but it's really just simplification, and you've done that before. And let me illustrate with something that's not yet in example 2, but this is going to illustrate what they call the key concept above. So say you have 28 over 8, and you've seen that before many times. You know that 78 is 7 times 4. Sorry, 28. And that 8 is really 2 times 4. And you can write it that way. And you can see that because these are all multiplied, you really have, 7 halves times 4 over 4, which is really 1. And so that you can simplify it to just 7 halves. Many of you have probably done something like this before, where you've done something that looks like this, and I'll just rewrite it. 7 times 4 over 2 times 4. And you just take your pencil, cross these out, and you're left with 7 halves, right? You may have done things like that last year as you were solving things. So all we're doing really is things that you've done in the past. This is nothing hugely new. And this just illustrates what they call the key concept, which you'll see at the top of page 795, which is if you have A times C over B times C, it really just equals A over B, as long as B is not equal to 0 and C is not equal to 0. Obviously, otherwise it would be undefined. So I'm just going to put that here because that's really just all that we're doing, and it's not really something new. It's stuff you've seen before. So let's look at another of these examples. We'll just slightly get a little bit more complex as we go. And say you have 25x over 3x. Well, here you can see that x over x, right? You can see the same thing that we did here, 25 times x over 3 times x. And you can just cross out your x's, and you get 25 thirds. So here we were multiplying just by numbers, right? We were finding the greatest common factors, or just taking this number apart into all its factors. Here we're taking the numbers apart in the factor that also includes variables. We can do the same thing with binomials or trinomials. So you can have 5 times the binomial x plus 1 divided by the binomial x plus 1. And here it's the same concept. You've got 5 times x plus 1 divided by x plus 1. Just like x over x is 1, x plus 1 over x plus 1 is also 1. So you can cross it out, and you're left with just 5 times 1, or 5. So that is really the essence of what we're going to be doing. And so, having just sort of given you an introduction, I'm going to launch into the actual lesson, okay? And, or the actual examples in example 2. And let me start with, let's see, what do they have? R divided by 2R. Okay. So I'm dividing r by 2r. Well, clearly I can see that this is something where I can cross out the r over the 2r right here. And I'm left with just 1/2. Let me look at b. For b, they have 5 times x on the numerator, and on the denominator they have x times the monomial x plus 2. Okay, so let me put it in a form where it's just a little bit easier to see. This means 5 times x over 5 times x plus 2. And I on top put 5 over 5 right here so you could clearly see that these can easily be crossed out because they mean 1. And I can see that my solution is just going to be x over x plus 2. Let's get slightly more complex as we were doing before in the intro. Here we're going to have 6m cubed minus 12m squared divided by 18m squared. Well, we can look at this and get the sense that you got a 6, and that goes into the 6, the 12, the 18. So it's got to be reduced. You can also see that you've got m cubed and m squared and m squared. So we know that we can reduce this. What's really important is to be systematic. And by systematic, I mean you have to be careful and go step by step. So let's start by, in the numerator, we're going to take out the greatest common factor and factor that out and see what's left in my parentheses. The greatest common factor between 6m cubed and negative 12m squared is 6m squared, right? Because between 6 and 12 it's 6, and negative 12, pardon me, it's 6, and between m cubed and m squared it's just m squared. So I'm left here with just m, because m times 6m squared will give me back as 6m cubed, and here minus 2, because negative 2 times 6m squared will give me negative 12m squared. In the denominator, I know that 18 is 6 times 3. I could see when I first looked at it that there's going to be something, right, divisible by 6, so I'm going to factor out my 6. I'm left with a times 3, and then I also have my m squared. And now I look at, okay, what do I have in the numerator and denominator that can cancel as long as everything is multiplied by each other? So because I have 6 times m squared times m minus 2 with 6 times 3 times m squared, I can cancel these two. And I can also cancel here, m squared and m squared. And so when I'm done, I'm left with just m minus 2 in the numerator and 3 in the denominator. Okay, let's look at D briefly, and we'll do 1 or 2 more examples before we move to the next thing. We have the expression y divided by 7 minus y. Now I know, and I see this again and again, many of you are going to be tempted to do this. In fact, I know I'm going to see this on a homework, so I'm praying you're watching this video, because you can't do that. You have to leave it as it is, and the reason you can't is if this were 7 times y, absolutely, but it's 7 minus y, and because of that, you can't do anything to it. You can't do any canceling, and so your answer is y over 7 minus y. In other words, you can't reduce. It's as reduced as it can get. One of the things that I should go back and look at, and I forgot to do, is what are my excluded values. So I've gone through A, B, C, and D, but I have not given the excluded values. So let me go back and do that. So for the first one, what is my excluded value for A? Well, to do the excluded value, I have to look at the equation as it was at the beginning. In other words, r over 2r. And I ask myself, what value of r is going to give me a denominator of 0? Well, that's just 0, right? If I have a 0, 2 times r is 0, so that's going to be 0. Let me now look at B. So, okay, what value of x will give me a denominator of 0? Well, if I have here 5 times x plus 2, right? If I get anything in the parentheses, that's going to give me, that's going to multiply by 5. So if what's in the parentheses is 0, and I multiply it by 5, I'll get a 0 in the denominator. So what would give me a 0 in these parentheses? Well, clearly, if x is negative 2, I get negative 2 plus positive, I get a 0, times 5 is 0. So my excluded value is 0. Sorry, is negative 2. I'm thinking that it gives 0 and I write the wrong thing. All right, negative 2. Sorry for that. All right, let's look at C. Again, we're going to look here and we can see very clearly the only thing that's going to give us 0 on the bottom is 0. So the excluded value for C is 0. Okay, let's look at the excluded value down here. What value of y is going to give the whole denominator 0? Well, you can see if y is 7, 7 minus 7 is 0. So positive 7 is going to be the excluded value for D. Okay, so that is example number 2. And I'm going to pause. I'm going to have you do guided practice 5, 6, 7, and 8. And I'm going to go over the answers very briefly before going to the next example, just because it's very easy to make a mistake.